Welcome, everyone. I hope you've been having a great start to the conference already with this online day, and I hope to see a lot of you tomorrow and the day after during the physical conference as well, to meet you in person. Oh, you cannot hear me. Can anyone else? Oh, okay, you guys can hear. Okay, perfect. Thank you for responding all so quickly. That's really helpful. I'm sorry, I'm not sure why you can't hear me, Caesar. Perhaps it's the volume, or it's that you haven't allowed Hopin to share sound, or you've muted the tab. I'm not entirely sure, but I hope you can troubleshoot it. If it doesn't work out, this session is also being recorded, so you can also rewatch it later, of course, with audio. Yeah, so I'm here today to talk to you a little bit about deploying generative AI models. I'll go through some best practices, and I'll close up with a live example where we'll be deploying Stable Diffusion together, and I'll show you how that works. Just some household things. If you have any questions during the session, don't hesitate to put them in the chat. I won't be able to see the chat at all times, so it might take me a little bit to get to your question, but I've got time for questions at the end in any case. And if you happen to have any more questions at the end, I'm also there tomorrow and the day after at the physical conference. We've got a booth, so you can also always visit me there if you want to discuss more after the talk. So without further ado, let's get started and let's head into this. So yes, maybe first, very nice to meet you. My name is Anouk. I'm the head of product at UbiOps, and my background is in nanobiology and computer science. And nanobiology might sound very unrelated here, but it had a large data science component. So I was working on a lot of data science projects, mainly in the biomedical field. So just to put my talk into context, I want to start off with saying what UbiOps is, the company I'm working for, because I'll also be using it at the later part of this talk. And I think it helps frame everything we talk about. Okay, so UbiOps is a user-friendly serverless inference layer for AI. It's basically built for data scientists, data engineers, and ML engineers to be able to run any kind of Python or R code in a scalable and production-ready way. And this is also what I'm going to be using for the example, just to show you. But without further ado, let's get started. So this is the schedule of what I'm going to talk to you about today. So I'll start, the introduction we already had, but I'll start to talk a little bit about deploying to production in general, what you need to take into account there, common mistakes, common hurdles, and then I'll continue to best practices when deploying Gen AI models specifically, just also to compare like what changes in that setting. Then I'll go through an example where I will live deploy Stable Diffusion. So let's hope that the Wi-Fi gods are with me today. And then we'll have some time for Q&A at the end as well. Okay, so deploying machine learning, or as I like to call it, getting machine learning really from the lab to the field, kind of involves this process of getting code that's on a local laptop that's like created in Python, in a notebook maybe, getting that to a state where it can actually start creating value for the business. Because anything that isn't deployed yet doesn't really generate value just yet. Like if you have to manually run it every time someone requests like a prediction, like that doesn't really work, of course. Now, sometimes I still get the issue like, oh, but what is the problem with this? Like, let's say it's some kind of internal process. Why would we need to bother with like getting this into a production ready environment? I hope that most of you will, of course, know what the issue is with that. Otherwise, you also wouldn't be coming to MLOps World. But just to recap, here are some things that you need to tackle when you start deploying. You need to make sure that there's access to the necessary data. Production data is very different from training data you typically get. So you need to make sure that your model will get access to that. Resources is especially important when we're talking about Gen AI, because it typically needs specialized hardware that might not be in any kind of standard laptop, but maybe it also needs a lot of memory. And scalability, like maybe if you need to run something every month, sure, someone can do that manually and that's not a very big problem. But if you have something that you want to put, like integrate into another product or that you want to put behind your website, you need to start looking into scalability. Like, sure, it's great if that model can handle one request at a time, but can it also handle hundreds coming in at once? Not to mention security and reliability, of course. So typically what I personally see, I don't know if this is something any of you recognize, is that for companies that are just starting out with deploying their machine learning models, their plan looks a little bit like this. Like, okay, we're going to start in some kind of Jupyter environment because it's nice for experimentation. Then once we're happy with that, we're going to cram that inside a Docker container and we're going to put that on the cloud and then we're there. Then it's done. And in essence, these steps are necessary, but in reality, there are so many different tools and frameworks that you'll need to work with to really get from A to Z. Because you'll need things like version control, monitoring, logging, scalability. Maybe you've got some on-premise servers, but also some cloud servers, and you need to be able to work with both. Not to mention the headache of working with Kubernetes directly if you need scalability. So it's not really a very straightforward process. A lot of steps have been made in the last years to make it a bit easier, but still there are so many things that come together when you really start deploying a machine learning model. That's also what we try to simplify a little bit at UbiOps. We really try to make it easy to go from code to a live application with its own API endpoint that's in a fully scalable state. So that's really kind of like where we come in. So I just wanted to share some things to consider when you're moving towards this deployment step in any kind of data science project or machine learning project. Regardless of whether you're using us, these are just some questions I think are always good to ask yourself. So make sure that your deployment process is easy so that iteration is easy. The thing with MLOps, when you compare it to DevOps, is that the iteration cycles are a lot shorter. So because you inherently don't know if your model is going to work until you put it to production, because production data is simply so different from the data you can train it on. And data is very volatile. It can change continuously, which can affect the performance of your model. So it needs to be very easy and a very low threshold to update a model that's in production when you see something's going wrong. Because if this process is very difficult, it's going to take very long, and you're probably not going to do it on time, or you're going to try to postpone it as much as possible. And that can really not only cause a lot of issues when we look at the financials, that you might be losing a lot of money, but it can also cause some destructive behavior from your model. Let's say there's a very heavy bias in it that you want to take out. You might not want to have that model so long in production when you know you can patch it. So the easier this process is, the lower friction. That's really important to maintaining proper performance also once you deploy. I would highly consider using shadow deployments to gauge the actual performance of your model before you roll it out. Not sure if you're all familiar with shadow deployments, but it's basically a technique where you deploy a model to a production environment and you run it in parallel with the model that's currently already in production, but the end consumer of that model never sees what that shadow deployment is doing. So you log it internally, how it's responding to production data, but no end application is dependent on what that shadow deployment is doing. It's just for your own confidence to see that that model actually works well also on production data, not only on training data. Also have a look at what the data traffic is you expect, because this can really have a big impact in how you should deploy it. So make sure you can also scale out accordingly. If you expect very spiky traffic, for instance, like let's say only traffic during the week and nothing in the weekends, then you want to make sure that you can scale out accordingly on the weekdays, but that on the weekends you're also keeping your resources low to keep everything a bit cheaper and more maintainable. This is something I see going wrong very often. Ensure that model versions can be safely updated without needing to update the API endpoint that's being used. So let's say you've got a website with a recommender model behind it. That website is communicating with the API of that recommender model, right? Let's say you want to update your recommender model. If you update that and the API endpoint changes, you not only need to update the model, but you also need to update the website all of a sudden, which can increase the burden of doing that update. So if you use a standard API endpoint format for your model, then you only need to update the model and the website can be left untouched. And that really makes it a lot easier also to put control back on the data scientist side to be able to update models and keep the performance in check. Okay, so that's regular deployment, but let's take a look at what changes when you start looking at generative AI deployment. So let's start with the definition of generative AI I'll be using here. So generative artificial intelligence, or generative AI, is a type of artificial intelligence system capable of generating text, images, or other media in response to prompts. So, and these are almost always neural networks. So when you look at deploying Gen AI models, the nice thing is that there's this general structure that you know will always hold. So you have some kind of text-based prompt, so some kind of string, and you've got your model that's being served behind an API, and you've got some output, and that output is either text as a string or any kind of file, so videos, images, or text files. So in my opinion, when you start looking at deploying Gen AI models, the fact that you know the structure so well in advance actually makes the deployment process a little bit more simplified than if you don't know what the structure is going to be like. But there is one very big hurdle that I would say is definitely different than when you compare it to deploying, let's say, normal or like a predictive maintenance model or something. And the hurdle there is the need for specialized hardware. Because these Gen AI models tend to be very big, they can be very slow when you put them on regular CPUs. And like sometimes you would even be looking at, if you would run them just on CPU at response times of, let's say, half an hour. I mean, you cannot open that up to an end customer, to like a consumer, right? Because they'll just think that your app is broken. You really need to be able to get that response time in, let's say, a matter of seconds to maybe a minute max or something, so that it's actually acceptable. And to be able to achieve that fastness, that quickness, you will need to start looking at specialized hardware, because normal CPUs won't cut it anymore. Now, that raises the question, what hardware should you choose? Because, of course, there are GPUs, but there are many different types of GPUs, so which is the right one to be using? And lately, there have also been a lot of other kinds of accelerated hardwares that have been surfacing, like IPUs and TPUs. So I made a quick overview of the pros and cons of each of these categories to hopefully give you a little bit of a framework to look at for what could be helpful for you, for your model, for your use case. So let's start with GPUs. Everyone's familiar with them, I think. They're very optimized for parallel processing. They were created for graphics processing, but luckily for us, graphics processing in the end is very similar to the kind of processing you do in a neural network. So that makes them very well suited for AI applications. They also work very well with big batches, and you've got a lot of different flavors here, which all have their own pros and cons and quirks as well. But one thing that's very nice is that you've got NVIDIA T4s, which are specialized really for inference. You'll be looking at different GPUs when we're talking about training, but we're discussing deployment and inference here. And in that case, T4s are often a good choice. If you need something more powerful, you've got, of course, things like A100s, but they're really beasts. So it's really dependent on what kind of use case you're trying to deploy. And they're also very expensive. That's also the downside, that each type of GPU has its own quirk, so you will need to do some digging into that to find out which is the right one for you. They also use a lot of energy, so if things like sustainability are an important part for your business, it's important to look at what kind of GPU you're using so that it's not using way too much energy for what you actually need. And it's built for general purpose because it's built for graphics processing and not specifically for AI. So it's not as optimized as it could be when it comes to this, although NVIDIA has been making a lot of steps here, of course. So then the next category are IPUs, short for intelligence processing units. Not sure if you're familiar with them. They're created by a company called Graphcore. And they are really pieces of hardware specifically made for graph processing. So really good for deep learning. The nice thing is that they have more availability than GPUs, although only on one specific cloud, on Gcore and Paperspace. But the nice thing is that with GPUs, sometimes they're very scarce. They've got these moments where there are not a lot of available. IPUs tend to be more available so that you have one readily that you can use. And they have a very large memory bandwidth as well. So the downsides, though, is that it's only on these specialized clouds, on Gcore and Paperspace, so it's not available in your general big three clouds like AWS, Google, and Azure. So if your company is stuck to using one of those, then it won't be possible to use an IPU. And they are very expensive. Last time I checked, I think they were slightly more expensive than if you would compare them to GPUs on the cloud providers. And then the last category, TPUs or tensor processing units. These are created or developed by Google, and they're also specifically made for deep learning, so they're highly optimized for that. The nice thing is that there's a lot of reference material for working with TPUs and a lot of examples that Google has put out there. But on the downside, it's more expensive than GPUs generally as well. Only works for tensor calculations, and you can only work with it through Google, although you've got AWS Graviton, which is slightly similar. So I hope that gives a little bit of an overview of the hardware that's out there that you can be using for this. Some contributing factors for your decision. I would say really have a look at what is the desired request duration. Does it need to be below a certain limit? Do you have some kind of service level agreement that you need to adhere to? Because the shorter your request duration needs to be, the more powerful hardware you will need to pick. How much budget is available? Can you really afford better suited hardware or more memory allocation? Or are you limited in that? Because maybe for your request duration, you would actually need to be looking at like an NVIDIA A100, but you don't really have the budget to be running that at the scale you would need to run it. So those two, you need to do a little bit of a balancing act, what you can work with. How big is the model? Does it really need a lot of memory? And always check also how the performance is on regular CPU. Because I have seen lately that a lot of people would just go straight to the newest and fanciest NVIDIA GPU if they've got some budget for it, even though the model actually doesn't need it and is like only using, let's say, 10 or 20% of that GPU. I mean, that's a bit of a waste, and that's a shame when a general purpose CPU could actually maybe be very suitable. For generative AIs, sadly, this is normally not the case, but I still wanted to put it in there as a little check. Any regulatory constraints? Does it need to run on a specific cloud? For instance, at UbiOps, we work quite a bit with some medical companies, and as you can imagine, they have a lot of legislations about where they can run their models, and they cannot really go on the big three. So they often have, at least for the European companies we work for, specific European clouds they need to run on. And then you're, of course, tied to what kind of hardware those clouds provide. And how much do you need to be able to scale out? Like, how much do you think you'll need? What is the data traffic going to be? Are you going to need to scale up to like 100 instances every day? Is that something you expect, or would you need to scale up to like 3 instances and it will be fine? That makes a big difference, especially when you're looking at like GPUs, which tend to be scarce. If you need to scale out very much, you will have to jumble through some hoops to make sure that you can actually scale out to that degree. But in the end, it comes down to this little pyramid almost of cost versus availability versus performance. And it's up to your use case and your company where you would fit in that pyramid and what your options you can make. So I cannot give you a clear-cut answer of like, oh, this is what you should be using. But I hope that these questions give you a little bit of a framework to work with here. Then one thing that's very important to always do is, of course, to benchmark and evaluate. You don't have to stick to the first thing you try, or you don't have to stick to what you wrote down on paper. You can just run a benchmark when you're not sure what to pick. So on UbiOps, for instance, we offer access to many different hardware types, and you can just try them out in a trial. So you can just try your model on, let's say, an A100, a T4, and an IPU, for instance, and see which one works best for your model, and also just see how it works with pricing for you. and of course evaluate after. And this is not only for like when you're making the decision, but also after you've made the decision, to keep an eye on like the monitoring for it, what the memory usage is, and how much of the CPU or the GPU you're actually using. Like, are you really using 100%, or are you using a lot less? Of course, hardware are not the only optimizations you can make. If you want to reduce your request duration, you can also look into code optimizations. Of course, there's a lot you can do with your code itself. But if you're using off-the-shelf models from Hugging Face, for instance, there are also some things outside of the code that you can use. For instance, here I put an example of NVIDIA TensorRT if you're working with NVIDIA GPUs. It's a framework that NVIDIA provides which helps speeding up processing on GPUs. It doesn't work for everything, and for some models it has better gains than for others, and it has some, pros and cons in the end. I put a link here to a blog post that details a comparison and a benchmark that we did with a specific model. I forgot which one on the top of my head. So you can see if that's something you would want to use. It's definitely one I would advise looking into if pricing is one of your concerns. So let's say you cannot use the best in class hardware that you would want to use, but you still have to get your request duration lower. Things like this can really help. Okay. That's what I wanted to discuss conceptually, and I think I've blabbered on enough conceptually now. So let's just dive into a live example where I'll just show you some code of how this would actually work. I'm going to take a quick look at the chat. Let's see. Oh, some people had problems with the screen share. But that seems to survive. Okay, perfect. I'll just skip through that. So only benefit of IPUs is availability, really. Once GPU shortage clears up, sounds like no real need to ever use it, especially since it doesn't support big three. So personally, I would say availability is the main thing because performance is similar. But pricing is more. So it's really an availability thing. Of course, they will also continue to develop. So maybe at some point their performance will outperform NVIDIA. I wouldn't be able to tell that because I'm not working for them. But I would say at the moment, the main benefit is really availability. So if you need to scale up very to like a really large number and you really guarantee need to have that availability, then it's something that can make the final decision. Let's see. There appears to be an assumption that you wouldn't use a cloud LLM, OpenAI plus others plus vectors. Is there a scaling point where using cloud becomes prohibitively expensive? Seems like low volumes are actually cheaper in cloud than custom hardware solutions, but no idea where the cutoff is. So, of course, you can also always use a cloud LLM, but you will still need some way of connecting with that because you cannot... like you will still need to connect it to your website and you want to have some kind of control. Like if you just hook up the OpenAI API directly to your website, you won't have any control about what's happening. You won't be able to monitor it. You won't be able to see what's going on. So it might be that people are actually doing very weird things or OpenAI changes something and that your app actually can't handle. So you will always need some kind of infrastructure in between to check what's going on and to keep an eye on that. But it depends on what you want to use. What I'm talking about in the context of this talk mainly is using off-the-shelf models from websites like Hugging Face, for instance. But there are always other options. Okay, see a bit too many questions coming in, so I'm just going to switch to the live demo or the live example, and I'll come back to the questions that I haven't answered yet at the end. Okay. So what are we going to build today? So your own stable diffusion deployment on UbiOps that you can send prompts to and that will return images. Stable diffusion, I'm guessing most of you are familiar with it. It's a latent text to image diffusion model. And every time you send a prompt to it, the response will be different. So it won't be like the exact same thing every time. And this is kind of how it looks. So we send in a text-based prompt as input. We've got this model running on UbiOps, and we've got the output coming back For instance, here I've got an example about dragons. I like dragons, so that's why I picked them. And to understand what this means, I wanted to quickly tell you what deployments are in UbiOps. So deployments are objects within UbiOps that serve your Python or R code. So when you deploy your code to UbiOps, UbiOps will build a Docker container for you, running as a microservice inside UbiOps, and it takes care of all the scalability so that it scales dynamically based on the data traffic, so it scales both up and down. So examples of deployments are either machine learning or AI models, but can be anything else that's Python or R code really. So that can also just be data processing code, connecting to a database, web scrapers, those kind of things as well. It doesn't have to be an ML model. So the steps that we're going to follow are, first, we're going to write the code for calling the AI model. Then we're going to deploy the code to UbiOps, and then we're going to use the model API to send data to the model. So without further ado, let's do that. I've got, I had a QR code here to scan for sharing it, but I'm not sure if it works. I'll share the link in the chat. Otherwise, that's probably easier. I've got a Google Colab that I'm going to walk you guys through. I'll share the link in the chat. Give me 1 second. Okay, it's this one. And to work with it, you'll need an account, a free account on UbiOps, which you can get from app.ubiops.com/sign up. Now, I would recommend you to just look while I'm doing it and not try to follow along at the same moment, because I won't be able to help you in case anything goes wrong, because we're with too many people. But everything here will stay available. Also, after the workshop, I'll also send an email with extra information as well. So I would say just try it in your own time and just follow how I'm going to do it for now, just because I won't have the availability to really help you if there's anything that goes wrong. Okay, so I'll show you the collab. So this is the Google Colab that you would see if you click on the link. If you have any problems with the link, let me know. Don't worry, there will be an email with the link in any case. But just let me know if there's anything there. What we will need is we'll need to work with the UbiOps client library, and the UbiOps client library will need an API token to set up the connection to my project. So let me quickly go to the web app. So this is the UbiOps web app. And I don't really, I've just got an organization and a project set up here. If you sign up, you will be prompted to do the same. And then within your project, you can go to project admin permissions, and that's the place where we can create an API token. So here you already see the tab for API tokens. I can create a new one. So I'm just going to call it MLOps World token. And I need to give this token certain permissions. So what I'm going to do for this one is give it project editor rights. So I'm going to assign that role. Go to the next step. Then I'll copy the token. Okay, so that one's created. So now switching back to the Colab, which should work. Let me check quickly. Yep. So now that we're in the Colab, first things first, you need to install the UbiOps client library. Oh, and by the way, if you try to run this Colab yourself, you'll probably get a problem like, hey, this Colab is not created by Google itself. Like, do you trust it? That's just the notification you will get for any kind of Colab that's not created by Google itself. So that's normal to get that announcement. Okay, so now we need to define like some environment variables that we're going to use a lot, and or some global variables that we're going to use a lot, and we can set up the connection. So in this place, like rule number or line number 5, this is where you will need to put your own project name. So my project is called Anouk Demo project. Swap this out for your own project name if you want to run this in your own project. And then if you run this, you will be prompted to put in your API token. So that's the one I just created in the web app. So I can just paste that in here. Okay, and it says status okay. So we've got the connection set up. Then the first thing we need to do is create a UbiOps environment. So the environment that has all the dependencies that our model will need. I already did this earlier. I'll run through it quickly, but I'll not run the last cell that creates it because I already did it. So we just need to give it a name, create a directory that will hold all the dependency information. Then here I'm just creating requirements.txt, just listing the requirements that my code needs. So of course the diffusers, transformers, those kind of things. So I can create that. And then I also need something which is called a UbiOps YAML, which is what we use for installing OS level packages using opt-get. So in this case, I just need one thing to make sure that my code will run properly on a GPU. And this is only needed if you're going to run on a GPU. Okay, so as you can see, I'd already made this environment. So I'm going to skip through these cells. If you're running this for the first time yourself, you will obviously need to run these 2 cells to create the environment yourself as well. If you're going to use a GPU, which is only possible with, which is not possible in the free account, so that's why I've got it by default here without GPU. But if you've got a paid account, you can put CUDA behind it, and we will get the GPU one. Okay, so now that the environment is ready, we can actually prepare the deployment code. So again, just making a directory for keeping all the code that we need. And then here you can see the actual deployment code that we're going to deploy to UbiOps. So UbiOps needs a file called deployment.py or .r if you're using R. Within it, a class called deployment with at least these 2 functions, an init function and a request function. The init one is the one we run whenever your model initializes. So this is for things that need to be kept in main memory. And the request function is what we run whenever new data is being sent to your deployment. So what I'm doing in this case is that I'm just getting the stable diffusion pipeline and already preparing that and to work properly with the right device. So GPU if the GPU is available. So that's what I'm checking here. And then in the request method, the only thing I'm doing is really piping the prompt that comes in, which is here. So I'm retrieving the prompt from the parameters of the function, and I'm piping that through the stable diffusion pipeline and retrieving the image that comes back. And that image I'm just saving and returning as the result of my request. So this is the code. So if I run this cell, it will write that to the deployment.py. Now that we've got our code ready, we need to tell UbiOps how this deployment is going to look. So for creating a deployment, deployments are structured with deployment, and each deployment has a deployment version. The deployment is more the high-level contract of how does this deployment look, and the deployment version is the part that actually contains the code that we want to run in specific settings. So when I create the deployment here, you can see that I just define what the input and output fields are. So I'm expecting a prompt input field of data type string, and I'm expecting an output field image of data type file. Okay. And then we can actually create the version. So in my case, I'm going to change this to use a T4 because I've got one available in my project. So I can now create this version. If you're using free, you will need to use it without the T4. Okay. And then now that we've created the version with the parameters we want, so this also contains like the scaling parameters, like how far do we want to scale up and scale down. For this example, I've just got it between 0 and 1. So that just means that it scales back to 0 when it's not being used. So now I can also push the code to that deployment version actually. And now we just need to wait until our deployment is ready building, because it will be building the package. Okay, it's done. So now we can actually create a request to this API that we've got now to make, well, not necessarily predictions, but to generate images. So I've got here as prompt a portrait of a green dragon. This morning I ran it and this came out. So let's see what comes out this time. So I can run this, and the only thing is that because this is the first time I'll be running this model, it will have a small cold start because it's the very first time it's spinning up, the very first time it's grabbing a GPU. This can take a few minutes for this one, so let me just show you what's happening in the background while we're waiting for that. I'm just going to share this tab and double check quickly if that works. Yep, you should be able to see that. Okay, so now if we navigate to deployments, you will see the deployment I just made. This is the one. So for the date of today, created a minute ago. We can check that. And here we also see the version that we have. So this is our version. And if we go to requests, the request is actually already done. We see the request that we just created. So let's go back to our collab and actually see what it came up with. Okay, so let's load the image that it has, and I'm going to quickly plot the image just so that you can see it. Okay, so this is the new portrait. It's something funky is going on with his legs for sure, but at least we can see that it's a green dragon. And now we've basically run through the whole process of creating a deployment, getting that API endpoint and sending data to that API endpoint. And if we go back to the web app, and one thing I wanted to show you, but the request was already done, is that you can always monitor everything that's going on in the logs. So you will be able to see how much it's using of like the GPU in this case, what it's doing in the background, when it's building, for instance, your environment, you also see everything that it's downloading in the background. Okay, I'll go back to this one and I'll go back to the chat. And I wanted to ask if anyone maybe has a suggestion for another prompt I should try, and then I'll have a look at the questions. So if anyone has a suggestion for a prompt, you can just put it in the chat. Otherwise, I'll come up with one. The last time I gave this presentation, someone suggested a blue dolphin, which was also quite cute. Corgi flying on a plane. Oh, I like that one. Okay, let's see what it comes up with. Let's hope it's not some kind of like thing of a nightmare. Corgi flying on a plane. Okay. Let's see. Let's also have a look quickly at what's going on. If we go back to our model. It's done. Okay. Let's see what it came up with. Okay, I think that's actually a pretty good one. Thank you. I think that's definitely been the best prompt I've had so far. So thank you very much for that suggestion. Okay, cool. I'll switch back to the presentation for my last slides with some extra information on it, and then I'll get back to the chat for the questions. Okay, so this we've done. I just wanted to summarize some key takeaways. So I would say that the process of deploying generative AI is not too different from deploying any other ML model, of course, with the side remark of what someone also very nicely put in the chat. It is different when you're using third-party things like OpenAI directly. I'm really talking here about deploying generative AI code yourself. Hardware choices play a big role for Gen AI deployment, so evaluate what's more important, cost, performance, or availability. Run a benchmark if you're unsure. Again, you can test out different hardware options on UbiOps, so send us a message if you need this, because it's not available on the free version, because that one only has CPUs, so we would need to set up a trial, but that's something we are more than happy to do. And also make sure that you continuously evaluate after you have deployed the model. Like, was your hardware choice the right choice? Is your model performing the way you assumed it would, etc. And with that, I want to say thank you so much for listening in and for paying attention and for asking a lot of questions. I'm curious to see what was all in the chat. I just wanted to mention that tomorrow we will be at booth 28 if you have any questions or if you want to discuss further. I've got a little map of the floor plan here. So when you come in through the entrance, we will be like here in the back corner with all the other booths and right next to the restrooms and stuff in that area. So if you want to talk more about MLOps or specific things about UbiOps, come and say hi. And that's it. Okay, let me go through the questions. I'm going to scroll up to the one that was the last one that I answered, because I see there are quite a few that came in the meantime. Let's see. That one I already responded to. That one too. Okay. So I see a question from Yinchi. I hope I pronounced your name right. My apologies if I just butchered it completely. Cloud providers provide options to control billing and usage gates based on ACLs. It is always recommended to utilize that to control costs. And yeah, for sure. 100% agree with that. It's the same what we do with UbiOps, really. And it's just very important to have those breaks in place just to make sure that something doesn't go out of control. A company I know, for instance, they recently deployed a new LLM-based chatbot to their website, and they were very happy they had these breaks in place because they became the target of a hacker attack where they were like just blasting this chatbot with malicious prompts. And luckily, because of the usage gates, everything stopped before it was too bad, and they immediately got the alerts that something was going wrong. So definitely recommend always putting breaks in control just to make sure that you can make sure it never reaches out of bounds of your budget. Another question from Philip. Are IPUs comparable to AWS Trainium/Inferentia? I believe so. I have not compared them side by side myself, so I cannot talk about the exact intricacies. Probably the hardware chips themselves differ quite a bit, but I would say that based on performance and why you would want to use them, I would say that they are probably quite similar. I'm not familiar with AWS Trainium, so I cannot really talk about that, but AWS Inferentia, I know. Let's see. For most Gen AI use cases, how do you think inference cost compares to training cost? So training costs for Gen AI are through the roof if you want to train from scratch. But I also think that that's something that nowadays isn't happening a lot, because with Hugging Face and OpenAPI or OpenAI, basically this whole training part of the MLOps workflow or the MLOps lifecycle kind of became a step you could skip, or where you would only need to use some fine tuning, but not really train a model from scratch. And because of that, the training costs in those scenarios are actually quite limited, because those training costs are on the people who actually trained the model that you're picking off the shelf. And in that case, really the inference cost will be a lot more than your training cost, because I would assume that you would have a lot more inference going on. However, if you're training really from scratch yourself and you really have those massive amounts of parameters that you want to train for, then it's a very different story. And then I would say that your training costs actually probably outcompete your inference costs. Also because for training, typically you would want to use even more powerful hardware than for inference, because inference is typically a little bit easier than training. But it really depends on if you're using something off the shelf or if you're training yourself. And also if you're training, if you're only training on a small data set, or if you're training on a very big data set, also has a big difference there. So that would be my take on that. I hope that answers your question, Rex. Okay. Then I see another question from Ritwick. How can we integrate this deployment with the user interface such as Chainlit, Streamlit? Very good question. Let me actually pull up an example for this. Okay. I'll also put the link to that one in the chat. So let me share this screen. So we actually have a deployment guide for Llama v2. Of course, that one's not generating images, but in the end, it works the same. It's still an API deployed on UbiOps. And we've got a blog post that actually also makes a Streamlit interface for this and shows how that works. So I'm just going to quickly plop the link for that in the chat, so you have that, so you can take a look at it later if you want to read all the details from it. So can I respond to it? I can respond to it in a thread. Amazing. Okay. I'll also put it in the general chat, but I also answered it specifically to your question. So let me scroll down. I think the example is also in here because the UbiOps deployment has its own API endpoint. So you can just send like an HTTP request to that to get the response back. And that way you can integrate it in your existing web app or like a Streamlit interface or a website. Let's see, I think there's an example of the Streamlit code. No. Is it this? Let me check. Yes. Okay. So this section is really for creating the Streamlit front end. So if you're familiar with Streamlit, a lot of the standard stuff is in here with like creating the sidebar, title, etc. The main thing in this case is that we're storing that, or for Streamlit, the nice thing is that you can use the UbiOps Python client library, which makes it a bit easier to send the request. So you can store the API token in your Streamlit secrets and get that. So that's what this code does. And then when there is, let's see, yeah, here's the function for generating Llama 2 response. So you've got the string of like the prompt that's coming in, and that one is being sent to UbiOps. So here we're getting the UbiOps API, and this is where we're getting the response. So we're just saying, hey, UbiOps API, create a request to this deployment version. We have to pass the project name, the deployment name, and the version name in this case. If you're using a default version, you don't need to do that. And share the data. So in this case, the prompt, and then the API, and then the result can be shown on the Streamlit interface as well. I think that's what's happening here. So I hope that that gives a little bit of an indication of how this would work. Of course, you can also just make the HTTP request directly. If you're working with, let's say, a JavaScript front end, then we don't have a client library that you can use, but we've got some example code snippets from that as well. The main thing is just that you have to create that API request. I hope that answers your question. Let's see. Yeah, I hope that answers your question, Ritwik. Then I see from Mubin, how much does UbiOps compare to a custom build from Azure? Good question. I would say that the thing is, when you're talking about Azure, Azure is not one product, right? Azure is basically this huge toolkit of a bunch of different services in there, which are all products in their own merit. And if you really want to build what UbiOps does with everything around it, with like the monitoring, the logging, the whole user interface, etc., you would really be looking at multiple different services that you would have to tie together before you get to the same point. Of course, that's possible. You can build something yourself. But if you work at a team where you don't necessarily have a lot of software developers or ML engineers on your team that would actually be able to do that and maintain that, then it would make more sense to use UbiOps. So we're not really a platform for, let's say, massive companies who have all the IT capacity at their fingertips that they would need and people who know how to work with Kubernetes. Like, then of course you can just do that yourself and make that investment. But we're really more geared towards people who either just don't want to bother with it because it's not their core business. So if you're not an IT or a software or tech company, then it doesn't really make sense to spend that amount of resources and spend so many of your people on building a platform to use internally. Then it might make more sense to just get one in there from a third party like us, or for, let's say, startups, scale-ups, or bigger companies where the data science team is fairly small. That's more where we would come in. So of course it's possible, but it really depends on what your capacity is. And of course there are some specific things that only we do, of which the main thing is that UbiOps is perfectly suitable for hybrid and multi-cloud setups. So in UbiOps, you can couple multiple cloud or even on-premise servers to your project and deploy to each and every single one of them with the exact same workflow without needing to like log into a new cluster or something. You can manage everything from one place. And that's, of course, something Azure cannot do, because with Azure, you're locked into Azure. Yeah. And we're also fully on-premise compatible. So, for instance, one of our customers is the National Cybersecurity Center of the Netherlands. And as you can imagine, they've got completely air-gapped bare metal servers that we needed to put UbiOps on. And that's also something that we're used to doing. I hope that answers your question. Then I see from Nan, can you talk about model performance monitoring on UbiOps, like model drift? So I want to mention here that like model performance monitoring is something that we currently don't have in the product or in UbiOps itself, but something that we integrate with other suppliers where we're much better at it, like Arise or Y Labs or Aporia. How that would look is typically that you would add an extra line to your deployment code that logs everything in the ML observability platform. And then in there, you can monitor everything like model drift. So model drift is not something that we provide built in UbiOps. We are working on some new functionality for keeping track of custom metrics, which would enable you to do this, but this isn't released yet. So this is coming soon. Then from Keith, how do you prevent P2 data from being submit to an LLM? I'm not entirely sure I'm familiar with the term P2 data. If you can elaborate on that or clarify on that, that would be really helpful. And then I can see if I can answer your question, but now I'm not really sure what's meant with your question. Personally identifiable info. Okay, amazing, thank you. Yes, so let me go to the web app and show you that. Because in the end, like, we don't provide code out of the box. It will be on you to write some code for filtering this. But how this works with some customers who have already done it, I just want to show you our pipelines. I haven't really touched on them for now, but in UbiOps, you can also create bigger workflows based on your deployments. And this is really where I would put in your prompt filtering and things like that, because we come pre-packed with some operators that are out of the box, things like conditional logic or applying a function. So with this, you can basically add the deployment that's really, like, let's say in my case, the stable diffusion deployment at the end, but maybe first you want a deployment that actually filters the prompts and checks if it's really okay as it is. And if it isn't, to like raise an error, for instance, raise a custom error and not proceed to the next step of the pipeline. I think I've got a prompt filtering example somewhere as well. Give me 1 second and I'll try to find that one. That might give you a bit of a better idea, because this is, of course, a general pipeline. Let's see, I think it's in this one. No, it's not in that one, but maybe here. Yeah. Okay, yeah, so here we've got an example of that where, so each green block here is a deployment in your project. So we've got the stable diffusion one, which is the same one that we just created. And we've got a separate deployment for actually classifying prompts and trying to filter out potentially dangerous ones. So let me have a look at what so in this case, it also classifies for sentiment. And if we see that the sentiment is classified as negative from this, like this deployment says like, ooh, no, that's negative, then we can, in this case, raise an error. In this case, it's just a very standard thing, like try another prompt. Of course, you can do one that's a bit more informative to the end user about why they need to change something. And if it's all correct, then it just goes to the model. Of course, you can build out on this and filter for more specific things. But how to exactly do that, that's not my personal expertise. But yeah, as long as it's written in Python, it can be structured like this. So I hope that that gives a little bit of an idea. Is there retry logic that is built into this? Yes, for pipelines there is. And for pipelines, there is also let me show you. We've got an on-error policy. So what needs to happen when the error occurs? So does this error needs to be raised, which basically stops the whole pipeline, raises an error, and the request finishes with status failed? Should we just simply stop the pipeline and not continue, but not raise an error? Or should we continue? So let's say you've got some deployments where you know, like, oh, sometimes this will fail, but it actually doesn't matter for the rest of the pipeline, that you can put it to that. And retry logic is also in there, but retry logic is within the deployment code. We've got a certain decorator that you can use where you can just put like on the decorator, like, oh, retry so many attempts with this certain interval, and then we will retry the request function if it fails. But we've put that in there so that you can also use it within a deployment and that it's not only limited to within pipelines. So that's how that will work. Okay, and what library are you using for the retry logic? I cannot say that on the top of my head, but I do know that it's in our documentation. And then last question from Bing, how to switch to another model like a customized model? Okay, thanks for asking this because it's actually a really good question. So if we have this pipeline and we would want to switch to a new version of Stable Diffusion, I'm not entirely sure if this one has multiple versions. What you can see here is that this one is currently using the default version, but I've also got some other versions here. So if I want to switch to a new version, I could either update which version it points to here from within the pipeline. But what I could also do, if I go to the model, so if I go to that Stable Diffusion model, what I can also do is I can update which one is the default. So currently the T4 one is the default. If I want to have the one that runs on an A100 as the default, I can simply just click this button saying, like, I want to make this one the default. And then this is automatically the one that will be used by the pipeline because it points to the default version. And this same logic you can also use when you put it behind like a web app, because there's an endpoint URL for the deployment, which always references whatever is the default version. So which is not dependent on what kind of versions you have or how they look, but it's really just whichever is the default, that's the one that's pointing to. Let me just switch it back though so I don't break anything. Okay, cool, perfect. I'm gonna stop sharing my screen because I see we're also reaching the end of this session. Or actually, let me just pull up the slide with where we are tomorrow real quick so that you can see that. So thank you so much for joining this session and for all the good questions. It was really nice that you were all asking questions and thinking along actively. I really appreciate that. Yeah, so thank you so much for joining. I hope to see you tomorrow or the day after, or maybe I think tonight there's this brewery thing from DVC. Maybe you'll see you there. Yeah, have a nice rest of the conference, and yeah, have a good day still.